Okay, so our topic is on linear congruences. Based on the definition of linear congruences, it's the simplest form of all congruences in the linear congruence. Of the form A is congruent to B modulo M, where X is the variable. It has a solution if and only if there are integers X and K such that AX is equal to B plus KM. The problem of solving linear congruence is essentially the same as that of solving linear Diophantine equation. So let's dissect the definition piece by piece so that we can understand it. So when you say simplest form, it seems to be it's linear, no? It's a line because it's so the highest power is if it's a line, then it's 1. So take note that it's the simplest form and it's linear. So meaning it's just X, because if other than that, you can have X squared, X cubed, and so on. So here you just have X. So if you have X, it's like saying you are looking for solutions. So we're looking for the value of X here. So where X is a variable. So it's like telling us that we can find the value of X. But how do we find the value of X? So the value of X is called the solution. And accordingly, it has a solution if and only if there are integers X and K such that when you multiply X to A, it is congruent to B plus K times M. So it's similar with linear Diophantine equations. So we can connect linear congruences to linear Diophantine equation. Later, we'll be using linear congruences to solve linear Diophantine problems. So we have here an example, 2x is congruent to 1 modulo 3. So let's find the value of x here. What should be the value of x? The first thing that we did was we looked for its modulo classes. So if it's remainder 0, remainder 1, and remainder 2, because it's modulo 3. No? So if it's remainder 0, this is 0, 3, 6, 9, 12, and so on. You can also include negative 3, negative 6. Okay. If that is 1, you add 3, that will be 4, plus 3, that is 7, plus 3, that's 10, 13, and so on. If you include the negative, then 1 minus 3, that's negative 2. You can have negative 2 minus 3, negative 5, minus 3, negative 8, and so on. Or if you have a remainder of 2, you can have plus 3, that is 5. You can have 8. You can have 11. If it's a negative, then you can have negative 1. You can have negative 4, and so on. So let's look into the case wherein it will be true. Again, we will if x is equal to 0, then you have 2 times 0 is congruent to 1 modulo 3. So 0 is congruent to 1 modulo 3. Is it true? 3 divides 0 minus 1. Will 3 divide negative 1? No. So meaning wrong ni siya. Dili ni siya solution kani sila. So di na siya mao. Kani pata ha, kani example number 1 ako lang siyang giklaro. Sige. Second, if 2x is congruent to 1 modulo 3. So if x is equal to kaning second nga koan, if x is 1 kana siya. So then you have 2, 1 congruent to 1 modulo 3. So 2 congruent to 1 modulo 3. Let's try if it's true. Will 3 divide 2 minus 1? 3 divides 1. This is false also. So that's wrong. So di ko di siya mao ang solution. Correct? Dito sa last, if r is equal to 2. So if 2x is congruent to 1 modulo 3, then 2, example, kaning si 2 imong gamiton. If 2 times 2 is congruent to 1 modulo 3, then you have 4 is congruent to 1 modulo 3. Is it true? Will 3 divide 4 minus 1? 3 divides 3. This is true. Tama? So this is the answer. Kani siya nga group. Therefore, for this example, the value of x is equal to 2, 5, 8, 11, ... Pwede po ka sa negative 1, negative 4, and so on. Muna yung value. Sige, any question on this? Klaro ba siya? Hello, guys. You have here 2x is congruent to 4 modulo 2. So in the first example, we only have one solution. Tama? Take out one solution running first example. Pinaka ka-solution sa second example. Kaya siya, 2x is congruent to 4 modulo 2. Okay, kung modulo 2 siya, unsay mga remainder gani? You have 0 and you only have 1. Tama? Unsay sulod sa remainder 0, remainder 1. So you plus 2. So 0, 2, 4, 6, 8, 10, and so on. Or you have negative 2, negative 4, and so on. So I think these are even, no? And the other one will be the odd. So you have 3, 5, 7, and so on. If that's negative, then you have negative 1, negative 3, and so on. Sige. What is the answer here? If you have 2x is congruent to 4 modulo 2. Let's try the first remainder. If it is 0, 2 times 0 is congruent to 4 modulo 2. So you have 0 is congruent to 4 modulo 2. Will 2 divide 0 minus 4? 2 divides negative 4. This is true. Therefore, this is an example. Okay, correct. So this is also solution ni siya, no? Okay. So first solution, you have 0, 2, 4, 6, 8, and so on, including negative 2, negative 4, and so on. So first solution, okay siya. How about the if it is equal to 1? You have 2 and then 1 congruent to 4 modulo 2. So you have 2 is congruent to 4 modulo 2. Is it true? So 2 is congruent to 2 minus 4. 2 divides negative 2. Is it true that 2 divides a negative 2? Check. So this is also true. So you have two solutions. Tanan kay solution. 3, 5, 7, negative 1, negative 3, and so on. So here you have two solutions, no? All of its modulo classes are solutions. Here you only have one solution out of the 3 modulo classes. Nasabtan ba siya? Hello? Jason? Nasabtan na siya? So, imot sang tanawon tanan iya ang modulo classes. Katubitong yung mga remainder. Dayon, if makita na nimo siya. But in reality, true to all din siya. Like kung gamiton nimo si 2 in replace ng 0, the same ra na siya. The same naman og sulod kung si 2 ang imong gi-times, no? Sige. But later, we will also have another way of dealing with it. Sige. Let's have the lemma first, this first lemma. If D is equal to the GCD of A and M, and if D divides B, then AX congruent to B modulo M has exactly D solutions. So when we say D, it is our greatest, our D is the greatest common divisor of A and M. So kung pila daw ang kung sa daw yung greatest common divisor, mao daw ang number of solutions. I-check in itong una be. Ang kaning pinakauna kay one solution ra siya, no? Check na to kung tinuod. What is the GCD of A and M man daw? So our A is 2. Our M is 3. What is the GCD of 2 and 3? Di ba 1? Correct? That's why one solution rin siya. Kani. How about this one? What is the GCD of the M? 2 and 2. Okay, unsay greatest common divisor ni 2 and 2? Di ba they are the same? Parehas naman sila. So you have here two solutions, right? Sige, let's have this one. For example, this one. What's the GCD of 3x is congruent to 6 modulo 3? What's the GCD? What's the GCD of 3 and 3? Sige, pila gani? Kung parehas gani nga number, unsa ang GCD? Katong last nato nga description, di ba? The same, 3, kung parehas. Like the GCD of 1 and 1 is 1. The GCD of 2 and 2 is 2. So here, the GCD of 3 and 3 is 3. Okay na. Therefore, nani siya itulo ka solutions. 3 solutions. Sige, let's find the solutions. Sige. So, ang una to buhaton is kuhaon to yung mga remainder. So, remainder is 0. Remainder is 1 and remainder is 2. So you have here 0 then plus ulit ka. Kung saan yung dire plus. So 0 plus 3, 3, 6, 9, 12. Kung sa negative ka, negative 3, negative 6, and so on. So 1, 4, 7, 11, and so on. Kung sa negative ka, negative 2, negative 5, negative 8, and so on. Dire 2 plus 3, 5, 8, 11, 8, 9, 10. So yun, din siya 10 din na siya. 11, and then you have a negative 1 plus 3, negative 4, and so on. Tana. So it's either ang remainder nimo is si 0, kanina ang mga numbers kauban, pwede po remainder nimo si 1 or sa remainder nimo si 2. If you say 3 solutions, then kani siya tanan solution. Tanaw to ko tinuod be. If 3 times 0 congruent to 6 modulo 3, will 3 divide 6 minus 0? Yes. So tinuod. So true na ni siya si r equals to 0. One solution na siya. Second, if 3 is equal, if x is equal to 1, 3 times 1 is congruent to 6 modulo 3. Is it true that 3 divides 6 minus 3? Yes. Because 3 divides 3. Okay. True na po na siya si r is to 1. How about when r is equal to 2? 3 times 2 is congruent to 6 modulo 3. So 6, will 3 divide 6 minus 6? Yes. Because 3 divides 0. So solution. So sakto katulog ka mo yung solution sa atong na-verify. No? And the lemma is true also. No? Any question on this? Klaro ba siya? So you can identify already how many solutions are there in a linear congruence by just making use of the greatest common divisor. Okay na siya. Sige. No question on this. Walang sanang i-erase ang kanina part para mukuan siya. Wait. Kaya ako na ipang-erase. I hope you are solving also in your seats. Okay, we have also another lemma. If the greatest common divisor of A and M does not divide B, then AX congruent to B modulo M has no solutions. So na po'y tendency nga walay solution. No? Kung ang GCD daw okay, does not divide B. Example, what's the GCD here? Anyone? The GCD of your A and M. Your A is 2, your M is 4. What's the greatest common divisor of 2 and 4? Ilaman, greatest common. Si 2? Or si 4? Pila ka buo? Isa lang? Sige ka na siya. So what's the greatest common divisor? This is 2, right? Si 2 man dyan na siya. And take note that we look into if it divides B. So si 2, i-divide ba niya ang value sa B, which is 3. Will 2 divide 3? Dili, no? Does not divide. So no solution din niya siya. Kaya no solution because your GCD does not divide B. Okay, how about this one? 4x is congruent to 12 modulo 8. Kana siya. So what's the GCD of 4 and 8? Sige, it's the greatest common ni 4 and 8. Diba si Koan? Si 4, tama? Greatest common divisor. So ang pinaka-common na ning duha is si 4. Sige. Will 4 divide 12? Tinood ba? Yes. Because 12 is equal to 4 and a k, which is 3. Therefore, this has 4 solutions. Okay. A comment on this, anyone? Jason? Ms. Rayoso or myself? Wala, okay ra siya? Hello?
Yes, sir. Nakuha ra.
Okay, sige. How about this one? In this lemma, we also have another lemma. The greatest common divisor of A and M is equal to 1, does not divide B. Then AX congruent to B modulo M has only one solution. So let's take a look at this one. So if you get the GCD here, the GCD of 2 and 3 is 1, right? And 1 will divide 3. It does not divide 3. But if you look into that, based on the lemma, you have one solution. Kana siya. Let's have it as an example. Pangitaon na to yung one solution. No? Supposed to be tulo man na yung solution kay modulo 3 man na siya. So R0, R1, and R2. When you have 0, then plus 3, you have 0, 3, 6, 9, negative 3, negative 6. Kung 1 plus 3, 4, 7, 10, pwede po ka negative 2, negative 5, and so on. Here you have plus 3, 5, 8, 11, or you can have negative 1, negative 4, and so on. Pakita ko na to, asa ang one solution. Kaya ingon man siya nga one solution. Sige. Does not divide na siya. Pero one solution daw siya. If 2 is equal to 0, congruent of 3 modulo 3. So this is 0. equal to 3 modulo 3. Will 3 divide 0 minus 3? Yes. Okay, so solution is 0. Tama? Nano tayo isa nga nakitaan. I-check na to kung solution ba ni si 1 o si 2 kay ma-invalidate atong lemma kung solution siya. If 2 is equal to 1, congruent 3 modulo 3. So will 3 divide 2 minus 3? 3 divides negative 1, wrong. So not a solution ni siya. How about si 2? 2 times 2 congruent 3 modulo 3. So you have here, will 3 divide 4 minus 1? 4 minus 3, I mean. Okay, 3 man ni, kani 4 man ni. So 3 divide negative, positive 1? No, correct. So naratay, isa ka solution and it is when x is equal to 0, 1, 0, 3, 6, 9, or kung sa negative ka, negative 3, negative 6, and so on. Nakuha siya? Tinood na? Hello? Hello, guys?
Yes, sir.
No? Maybe later at home, you try to check if 2x congruent to 3 modulo 4, wala siya solution yun, no? Wala na nato i-verify. Sige. Let's go to another concept. This one. So we are now in the remarks. We're done looking into the possibility of those concepts. The first is that inspection is one way of solving congruence with small modulo. Pwede ta katong gibuhat kanina, nag-inspect rata, no? Kaya gipangita na to ang mga katong yung mga remainder. Kaya gamay man to, 4 man to, 3, 2, and 1 modulo. Pero kung nana ka sa modulo 100, modulo 99, wag lisod na kaayo nga imo siyang i-check kada remainder, tama? So kato siya, katong gibuhat inspection pa gito siya. So there is another method is trial and error. Pwede pud ka mag-trial and error. Katong same atong gibuhat ganihan, no? Aside sa gi-inspect na to, trial and error pag kita nga okay kani check ba ni siya. This can be done by substituting an integer r where it is from 0 to m. So example, ang imong modulo m kay modulo 4 man to. So meaning ang imo ang r is possible lagi na 0, 1, 2, 3 siya wala pa sa 4 mo to tong gibuhat ganiha. Kung ito ang i-discuss in the last meeting. Na kung modulo 4 siya, ang imong remainder, gikan ka 0, 1, 2, 3. Wala dapat si 4. Right. And then the best way to manipulate the coefficients until cancellation is possible. So better kung maka-cancel ko later on. So let's try this example. Sige, kung 15 na siya, no, maglisod na magita. Nga ka nang i-solve siya kay 15 na good na ka remainder. So unsaon siya nga dili ta mag-try atong kaganiha or unsa pinaka best way nga ma-solve mo siya mas dako naman yung modulo. Sige. At sige, try na to nitong gibuhat kaning sa remarks. Method 1, inspection. Sige, try na to nga i-inspect na to siya. Okay, kani atong i-solve ha. Okay. Take note, our A here is 4, our B is 1, our M is 15. Kana siya. So for the greatest common divisor or sa fraction denominator man siya, if the GCD of A and M, 4 and 15, that is 1, correct? Wala man ay common sa ila, kang 4 o kang 15. And also, if the GCD will divide B ba, kaya siya kay GCD of A and M na. Will 1 divide 1? Yes. Therefore, you have one solution. Okay. So, kabalo na ka nga naka isa ka solution. Asa ka sa remainder sa modulo 15? Si 0 ba? Or dito ka kang 14 ang makahatag og solution? Meaning mo correct siya sa tinuod. If you have inspection, mamili lang ka dito. Asa gaya makatinuod ani be? Si 15. kana man siya, atong idea is si 15 dapat divisible sa kaning makuhaan ni. Dapat unsay maka-divide kang 15 kana atong unang nga question in mind. Di ba kabalot nga kung 4 ni si x kana, kung 4 na si x mahimo ni siya nga 16. Dayon if 16 minus 1 that is 15. 15 divides 15 and this is yes. So meaning ang correct nga kuan through inspection wala ta nagkuan nagtag na ta nga kinsa ato lang gi-inspect no substitute ta. So ato lang kita si r equal to 4 ang correct nga answer ang atong one solution. So meaning those values of x with 4 remainder nga 4 so mag-plus ra ka 4 plus 15 that is 19 or kung mag-minus ka sa 15 that is negative 11 and so on. So, kana din siya, 4, 19, mga negative 11, dagan pa din na siya. So, kana din siya ang correct answer. And we only have one solution. Sige. Nakuha ba ang inspection nga method? Hello? Hello, guys? Okay siya?
Nakuha ra.
So gitan-aw ra nato siya. Wala man ta nagkuan. Kung maing kag trial and error, i-substitute nimo si remainder 1, i-substitute nimo si remainder 0, si remainder 3, remainder 4. Then trial and error man to makita man nimo nga wrong si 1, wrong si 2, wrong si 3, ana. Then check din si 4. At least kita na nimo ang solution. Muto siya ang trial and error. Pero ang atong ikuan karon is kanang katong manipulate the coefficients. Possible po ba siya, no? I manipulate na to ang coefficients. So, to manipulate the coefficients, pwede ta maggamit gigamit na to sa Diophantine. Okay? So, ang method to is trial and error. Di na ako siya ikuan ha. Kay, anyway, ang trial and error, i-try raman niyo siya. Dito sa method 3. Method 3 is manipulating coefficients. Okay. So, di ba, paano na siya? 4x is congruent to 1 modulo 15. So manipulating the coefficients, natin cancellation nga buhatan. So, you have 4x is congruent to, kung ato na siyang i-convert into an equation, it will become 1 plus 15 times k, no? Where k is any integer element of the counting numbers, n. So, pwede ito let k is equal to 1. So, we have 4x is equal to 1 plus 15 times 1. So, it's just equal to 1 plus 15 ra. So, muna akong gitry ganiha dito, no? In the first part. But wala na akong ipadayan. So, here, 4x is equal to 16. Kana, di ba? So with this, ato man ni siya, kana siya. So pwede na to siya ibalhin dito. So mura bitawag atong i-koan. Like, kato si 1, pulihan na to si 16. Kaya equal naman na siya, nag-add naman ka, di ba? Kung kuhaon mo si remainder 1, kung kuhaon mo si remainder 1, equal na siya sa nag-plus ka og 15, 16, si kuan. The same na sila. Kana si remainder 1, 16, mag-add pa kag another 15, 31, and so on. Same na sila. Or bisan pag negative 14 imo ibutang siya, the same ra na siya. So imo ra nang gipulihan. Ikabalo man ka nga si 1, similar ra na ni 16 of the same class na sila. So imong gibuhat is si 4x is congruent to 16 modulo 15 kana. So imong buhaton, divide na nimo by 4. So x is congruent to 4 modulo 15, no? So nakita nimo nga ang iyang value di ay nga answer is kato si 4, no? Si 4 o ang iyang mga kauban. Nagets ba siya? Hello? Pwede mo siya pulihan kani si 1. Nga possible ka nga maka-cancel, no? Hello guys. Sige, let's have another example anang mag-manipulate bitaw og kuan. Okay. Sige, try na nato ha again. You want another example? By the way, mangita ra ka og K nga possible. Pero kung wala kay makitaan nga K nga possible, like dili pwede si 1 kay di siya maka-cancel kung si 1 imong pulihan. Nga K, kani ba? Di ba? K1 naman imong gigamit and possible na siya. Pwede po na imong siya pulihan og 2. Mangita jud ka og K nga possible na dayon siya ma-cancel. No? Sige, later na lang siya. Let's try to have this one. We will be solving linear congruence. No? To solve a linear congruence, AX congruent to B modulo M, where D is the GCD of AM and D divides B, or ang GCD ka divides sa B. You can also do this. Reduce the congruence to A divide D, X, and then B. Katong gibuhat nato or ganiya, pero kani siya wala man ta nag-divide sa modulo, no? Tanawa ganin no, si A gi-divide sa D, si B gi-divide sa D, o si M gi-divide sa D. Wala man to siya gi-divide. No. This is just possible if D divides B, no? Ang GCD nag-divide sa B. By cancellation, solve the solution, say R, and then write the congruence in the form X is equal to R plus K, M divided by D. So substitute K, pwede ka mangitag mga K nga 0, 1, and then the values of X obtained will be the solutions. Pero dili kay siya inga naka-clear ang ano. One way to do it, to clarify it, to solve a sample. So let's have this example. 30X is congruent to 27 modulo 33. Sige ka na. Let me have another screen. Okay, ka na. Hinga screen ako ikuan ha. Okay. Let us solve 30x is congruent to 27 modulo 33. Kana siya. So the first thing that we will do is you look for A. The A is 30. The B is 27. The M is 33. Then after that, you look into the GCD. The GCD of M and A is 30 and 33. Nakapa na sila GCD. Sa greatest nila. Di ba, puan man na sila multiples of 3. No? 3 times 10 is 30. 3 times 11 is 33. So the GCD is 3. And 3, will 3 divide 27? Yes, because 27 is equal to 3 times 9. Therefore, you have 3 solutions. Kana siya. So, kita na nato. So, karon ang atong buhaton, pangitaon na to yung mga solutions, no? Unsa ka ang mga solutions? So, let K is equal to 1. So, you have 10x. Wait. Ato sa din siyang i-simplify. So, let's simplify this one because we can divide this by, I think we can divide this by 3. So, 30x congruent to 27 modulo 33. So, divide this by 3. Divide this by 3. Divide this by 3. So, you'll have 10x is congruent to 9 modulo 11. So, kanina itong gamiton ang simplified na form. So, the first is let k is equal to 1. You have 10x is equal to 9 plus 11. Nag-ingon man tang atong k is 1. So, kana siya dira. 1. So, 10x is equal to 20. So, divided by 10, x is equal to 2. Therefore, one solution that we have is x is congruent to 2 modulo 11. Kana siya. No? So, with that in mind, nanatay isa. So, nanatay isa ka solution. So, pangitaon pa nato, ingon mo katulog ka solution. So, mangita pa ta sa upan. We can make use of this na. Di ba? Gamay naman ni siya. So, if we simplify this, this will become x is equal to 2 plus 11 times something. But 11k. If you let k is equal to 0, 1, and so on. So if k is 0, x is equal to 2 plus 11 times 0. That is 2. Okay, the same na siya, ana. If k is equal to 1, x is equal to 2 plus 11 times 1. So you have 2 plus 11. So this is 13. Kana siya. And then another is, if k is equal to 2, you can have x is equal to 2 plus 11 times 2. 2 plus 22. So that's 24. Therefore, the values of x that we have here could be 2, 13, and 24. These are our answers. And its other classes. Like if mag-add ka og 33, kana siya, so apil pala niya si 35, kani apil niya si 46. Ana. No, but if you are in the realm of 0 to 32, so ang imong value sa x kasi 2, 13, and 24. So these are the 3 answers that you have.
Sige, ma'am.
Any question on this? Hello. Hello guys. Klaro ba ni siya? Myself,